have to work in SI units, right? Right. There's a little mistake. There are two mistakes here. Anybody seeing them? Yeah. Yeah. You sure? It have two mistakes there. Temperature is in Kelvin as well. Absolute temperatures in Kelvin. You'll see that later on. So this good. This good. This good. This good.
Meter and second should be common.
Right. The meters should be common, right? Who was that there?
Nikolai Batiste.
Nikolai, right? Nikolai, I mightn't hear you all the time. I say if I don't hear you, just message, right?
Yeah.
Right. Very good. Meters should be common M and time should be common S, right? Lowercase. Okay. But these are the base quantities. We need to know base quantities, right? Because every other quantity will be based on this. So for example, area. Area is an example of a derived quantity, but area is two lengths. So it's meter by meter. That's why the SI unit for meter is for area is meter squared. Okay. So you can't work in centimeters or millimeters, you work in meters. Okay. So let's make a note of that in case you never saw it before. Let's make a note of this base quantity table. Okay, nice. So the reason I gave it that is because here, if you look down here, here's an example of some derived quantities. You may not know all of them, like density and force something, but I just wanted to know the units. So let's do my favor now and just copy down these. These are some of the important ones. Write them, both of them. So for example, force. Force is measured in newtons, but is also kgms minus 2. Okay. So I want you to know that work and energy is in joules, power is in watts, pressure is in pascals. So let's do my favor and copy down this table. Okay, before we go into our first topic. I'm going to finish, right? Ready have it? Right? So we're going into our first simulation now. Right? This here is your first simulation. Everybody okay with that? Yeah? All right, good. Let's take a look at them. Generally, all my simulations I use this website here. Right? Any topic you do in physics, go look for a simulation, go look for a video and see how everything really works. All right. We might not have the apparatus here to do it, but there's a simulation for it, right? Right. So normally I use PHET, Colorado University. All right. So let's see. This is our first topic that we're going to look at. It's called moments. You would have seen this already on a seesaw. Or there was not seesaw before. Yeah, there was not seesaw. Right? A homemade seesaw or actual seesaw. Or any part. All right. So what's just here? So what we're going to learn about is something. Am I on your phone now? No? You're just looking down at the book. All right. Right. So what we're going to look at here is something called the principle of moments, right? You'll experience every day. Every day you'll apply moments to different objects. For example, if you open and close a door, right? You are creating a turning effect. So when you open the handle and you push a force and you apply a force, you're turning the door outwards, right? When you apply the force inwards, you turn it inwards. So the moment is the turning effect. That's okay, right? Just a quick question before I move on to this, right? Why you think they place the door handle in the middle there? Why they didn't take the door handle and put it in the middle of the door or the end of the door, right next to the hinge? Any ideas why? Why they put the handle all the way to the end there? Look at the door there. See where the handle is? Why they didn't put the handle in the middle? It might look nicer in the middle, huh? What do you think? Very good, right? Because the further away you go from where the hinges are, the easier it is to open and close the door, right? The reason for that, you'll see in a little while, is because the moment is the largest. Are you okay with that? Right, so that's very good, right? That's one of the reasons why I said something about the end of the seesaw as well. The moment is larger there, right? So they put the handle further away from the hinges because the moment will be larger the further away you are. Okay. So let's see. So if you look at this seesaw here, right now this seesaw is level. You'll see that? Seesaw is level. If I were to apply a 10 kilogram mass to a weapon, it causes the seesaw to go on the right hand side. So the turning effect there is as a result of the 10 kilogram trash can. Okay there? It gets now you learn to work it out, right? Suppose I wanted now to balance it off. What to do? Let's use the 5 kilogram. Suppose I wanted to balance it off. What do I do? Place the on the next side, anywhere? At the end or at the exact same spot? At the exact same spot. Yeah? Online, anybody could guess? Why is that now balanced? Why is that now balanced?
Because actually, because the weight is not the weight is equal on both sides.
Because the weight on each side is equal, right? I think I speaker. What is speaker for here, boy? Where is the speaker? Right, yes, he said because the weight on both sides equal. Are we looking for something else as well? Right? Right? I'm gonna show you this. If I were to remove the mass off, right? What direction did it turn? Clockwise or anti-clockwise? Clockwise, and now if I were to just happen there. Right. If I take this one off, it turn what? Anti-clockwise. So here's really what happening. In fact, what do you think happening there now? It's in equilibrium. And the reason for that is that the clockwise and the anti-clockwise moments are the same. Okay? But I want to introduce to you the concept of moments, right? So let's just take this little definition here for moments, right? You can write it as now. Just always, once I explain, try to listen first and make sure you understand. Don't try to hustle the note. At worst, it's online, right? I will send you notes. I will send you everything. Okay? So you don't have to worry too much about trying to write down everything. Try to make sure you understand, right? And make sure every question we do, you understand, and you try to move ahead. Like if I give you an example, all the others, you try and do them. See how far you can reach. Okay? All right. So don't worry about trying to run down and get notes, because I will give you notes for every single topic. All right? Right, so moments. Let's just say I gave you a plank, and the end of the plank, I stick a nail in it. So that end cannot move. Right, I can see that. Wait a second time. Oh. Right? So the end of the plank, I stick a nail in it. So that side of the plank cannot move. If I were to apply a force here, if I were to apply a force there, what direction will it turn? Will it turn clockwise or anti-clockwise? It will turn down like this, right? So it will turn in a clockwise direction. That makes sense? So that force is creating a turning effect. And moments is really the measure of the turning effect. This will happen whenever every time I charge. Right? So how do we work out turning effect? Turning effect is equal to the force applied multiplied by the distance from the pivot. That's this distance here. Okay, let's call that D. So whenever you multiply the force by that distance, is really perpendicular, but I won't focus on that yet. But force by distance is the moment of its moments. That's okay. So every time you multiply the force by the distance, that's a moment. And the SI unit, is Newton. Bastard boy. Just close it there for a minute. The SI unit is Newton meter. So it means that you're working in newtons and you're working in meters. That's okay? All right, so head up moments, take this small note. Take this small little note, and then you could write down what you see in there, right? That's a small note I want to give you. We're not going too far into this thing, it's just an introduction, right? This is one of the hardest topics in mechanics. I don't want to say physics, mechanics. It's one of the hardest topics. These past because people don't like them. Right? Right. Let's take this small note, the moment of a force. The moment of a force is the measure of its turning effect. The moment of a force is the measure of its turning effect. Full stop. All right, and write this part here. We'll write what you see in there on the board. I copy that what you see on the board there. Right, good. Alam that? Right. How come the SI unit is Newton meter? Anybody guess? Right. So force is in newtons, right? Force is in newtons and distance is in meter. And when you multiply them, you'll get Newton meter, right? Nice. Really easy stuff, right? Hamlet, are you okay there?
Yes, sir.
All right, good. Okay, nice. Nice. Okay, good. So let's just practice with some numbers before we go to the app, right? Good. Let's find the moment here. I am so hungry. I am so. Huh? Are you hungry too? I don't know what's up. See, around 10, 11, my womb just started to act up on me. All right, so let's say we have this. $20 newtons and the distance here is 2 meters. You see that? See if we can find the moment there from 20 newtons and it's 2 meters away. Right? SI unit. Even if you're online and you're messaging, is especially physics, message your SI unit as well. So you'll come for maths and advanced, right? All. So it means I gotta wake up early for 8 o'clock. Nice. What I got you? How much you got? 40 Newton meter. Okay, that's how it's important, right? So it's 20 by 2, which is 40 Newton meters. Number 2. Go ahead. Work out number 2. 16. All right, I see some people. I catch them already. I caught a few people online. See if I'll catch anybody face to face here. I caught a few people. Mr. Harichan, you there? Okay, I just checking on you. The name, right? Oh, Stefana, you put the thing right underneath. I wanted to give it a little breathing room now, a little space. No, you put form for physics right underneath here. I want you to do it like lower. Very good, very good. Right, when you all start logging up, like when you all join class, I'm going to show you all how to help me with the rule, right? You have to log on something and just tick in it or tick person. So I'll have a rule every week. Right, I'll show you how to do that. All right, let's check out this one here. Moment is equal to force. Is it the correct unit? Yep. But the 5 centimeters in the wrong unit. So we have to convert centimeters to meters. So you divide by 100 and you'll get 0.05. So the answer is 0.5 Newton meter. Okay, one more and be done. Everybody okay with that? So the first thing you look for, that's why I gave you that table. The first thing you look for is you look to check and see if you're working in the right SI units, right? That's the most important thing. Every question, you read the question, make sure the SI units are correct. This one, I'm not sure if you all know how to do this. Right? You should be, but I'll help you out as well. What's the problem here for this one? Right, kg instead of newtons, right? How do we go from mass to force? Huh? Mass by gravity, very good. Right? Multiply the mass by gravity. Because remember, the force a mass will exert is its weight, right? So what we have to do now is to find the weight of this object. And we know that weight is mass multiplied by gravity. Okay, so that would be 12 kilograms, and we'll use 10 for now, right? So the answer is 120 newtons. Right, so we could go ahead now and find the moment. So that'll be 12 multiplied by 10. Sorry. That will be 120 multiplied by 10. 1200 Newton meters. Okay, everybody okay with that? Nice. Let's go back to this simulation now. Everybody okay online there? Brandon, are you okay there? Okay, nice. Everybody good? Nice. So let's go back to this simulation. So if you look at the simulation, right? I think there's a way to put markings, right? Right. You can do me a favor and see if you could find the moment of the, I'll leave it there, right? Could you find the moment of the fire extinguisher on the right hand side and the left hand side? Find the moment of each one. You'll see the numbers. The mass is 5 kilograms and it's 2 meters from the middle. The middle is the pivot. Okay, so I want you to find the moment on the left hand side, right? I want you to find the total, the moment on the left and the moment on the right. And tell me what you notice about them. All right, nice, nice. Work out the moment on both sides. Mara, again, sure. It's easier than this. Or can you shuffle move? Yeah, do that. Go on the school YouTube channel and look over the video on introduction to section 1. Okay, look over this video. Right? Ready? So on the right and the left, they both equal. You recognize that? So on the right is you have to multiply. You have to multiply 5 by 10. So that'll give you 50 newtons. And then you multiply by 2. So here's 100 Newton meter, which is the 50 multiplied by 2. Same thing here. 50 multiplied by 2. And you end up with 100, right? 100 Newton meters on both sides. Okay? You remember what you said on the right hand side? What type of moment is that? Clockwise or anti-clockwise? On the right hand side. That was clockwise, right? And the left hand side, anti-clockwise. So what did you learn? You learned that the clockwise and the anti-clockwise moments are equal. That's okay? That is called the principle of moments. That's the first law, the first principle that you learn. Okay? So head up principle of moments and take that small little note there. The principle of moments, principle of moments states that the principle of moments states that for a system to be in equilibrium, the principle of moments states that for a system to be in equilibrium, sum of the anti-clockwise moments, the sum of the anti-clockwise moments, the sum of the anti-clockwise moments about a pivot, the sum of the anti-clockwise moments about a pivot must be equal to the sum of the clockwise moments about the same pivot. All right, I'm starting over this now, right? In case you get lost. Must be equal to the sum of the clockwise moments about the same pivot. Right? Quickly, the note is the principle of moments states that for a system to be in equilibrium, the sum of the anti-clockwise moments about a pivot is equal to the sum of the clockwise moments about the same pivot. Everybody got it? Yeah, and you'll see it there. All right. So here's my question to you now. I am leaving the fire extinguisher on the 2-meter mark, but I want to figure out where to put the trash can so that we balance it out. Right? But work it out. Show me in working. Right? Can't do it in working. Some of you will figure it out already. Where it have to go? At the 1-meter mark, right? So at the 1-meter mark, it will be clockwise equal to anti-clockwise. That's okay. So for this example here, just do this now. Just do this quickly in a book for me, please. Draw a plank, pivot, draw a box here. The force is 50 newtons and the distance is 2 meters. Then draw next box. Distance is 100 newtons and the distance is x. Okay. And then you have to work it out. Real simple, real simple, right? It'll be 100 is equal to x by 100. So x is how much? 100 divided by 100, which is 1. That's the reason why it works at 1 meter. Online, any questions? Avani, any questions? Nikolai? Brandon, all okay? Everybody good? Everybody can learn, man. So as I said, your lessons will be on a Saturday, right? The good or the bad thing is that all three on a Saturday. Add maths, then physics. From 8 o'clock to 12:30 every Saturday. And you have class on during the week as well, on a Monday. And when I'm making it right, physics on a Friday. 3:30 to 5. No, it's not physics, it's just maths and maths, right? You doing physics in school? No, okay. I think we're trying to do. Advanced school 7. But now it's the same timetable as senior. And it is saying late, well, we'll stay and practice. You can come during the week. See, during the week I've been on a different topic. So on Saturdays, after the first month, you can come to anyone. So Saturdays is like Form 4, what you do Form 4 work in school. On the Wednesday, I wouldn't say it's Form 5, it's a different topic. So if you start from the beginning, you could follow. I mean on Saturday, sorry, Wednesday is maths. Friday is physics Form 5. Saturday is Form 4. So you can come Saturday, guaranteed you have to come Saturday, and you can come Friday as well and look at the topic. Once you start at the beginning of a physics topic, you wouldn't get lost. But you can't start in between. So if I start in electricity, you have to be there for that start of that class. Or at least watch your video and catch up. If you come in the middle of a physics topic, you'll be lost. Right? But if you start at the beginning, simple. You can do any physics topic once you know physical quantities and things, you can do any physics topic. There's no overlap really. No. All right, let's change this up. Let's change this up. So I want to know where to put. Hold on, huh? I am putting where to put the fire extinguisher. And I put the trash can at 0.75. Work it out. Try to work it out manually first, and then we will try it out here. Those who online, work it out first, right? Try to work it out. Where do I put this? Right? Where do I put it? So draw back the same diagram for the X, and then let's see if we can work it out. Right now it's not working. Where do I put the fire extinguisher? Wait, don't message us yet. Take your time. Try to work it out just like this, right? Just like the last one. See what I have it here? Right? But just put in the values for this new one, for this new question. Draw a little plank, put in your bar, try to work it out. The values here change, right? See it? Finish up. Try it for me. That's what you come up with. Right? That's all the edit and see good. Okay. And then move it. Just down with it, right? Let's get in contact. Move it out. Let's see what we are. I mean, I look up the how fast? and then we'll. Okay. And let's see how it looks. Right? Let's see what Devana got. She said the put in that 1.5. Let's see if you'll get a green arrows. Yep. 1.5. Okay. But I want to get any habit that will be good here. Okay. So here's how the working will look. Right? Every time you answer a question in physics, right? You always give them your answer in this format. Formula, then you substitute, then you answer, right? Well, when CXC marks it, that's the way they mark. Give you 1 mark for formula, 1 mark for substitution, 1 mark for answer. Okay? Getting the habit of putting the answers like that, right? So the formula here is the sum of the anti-clockwise moments. That symbol means sum is equal to the sum of the clockwise moments, right? Anti-clockwise is 5 by 10 because we try to find the force multiplied by x. Clockwise is 10 by 10 because it's now a force multiplied by 0.75. So here is 50x is equal to 100 by 0.75 is 75. So again, you recognize how important the maths is here. If you can't solve an equation, then you will struggle with physics. So then you might think physics hard. When the physics is easy, but the maths is where you're struggling, right? So that's why I will spend so much time in maths on making sure you can solve, right? X is equal to 75 over 50. And you got 1.5. What did I leave out? What I left out in? The units, right? Meters. So X is in meters, right? Well, yeah, you can see here is meter too. Everybody okay with that? Yeah? Copy down this whole thing here. I'll copy this down. Let's turn it into a past paper type question now. A little bit. Past papers have like 3 forces. Write it down. We'll take a picture, write it down. Take a picture and never look at that picture in your life again. All right, let's go again. I don't want the numbers to be too bad, right? But here's what I'm doing. I do not know where to put. I want to put the what you call it? I want to put the trash can. I don't know why that not coming. I want to put the trash can somewhere to balance it off. But I'm leaving the two fire extinguishers at the 2 meter and 1 meter mark. Work out where the 10-kilogram trash can should be. Okay. Same principle, add up the moments on the left and it should be equal to what on the right. Try to work out where the trash can should go. Try to work it out, right? Right, let me see, where did I reach? Here's a one. Work it out. If you think you have it, I'll ask somebody to put it in the right place. All depends on. So this, I count this to be first time I realize this is what I have become. Huh? Yeah, I have become a Crocs person now. I wear a suit and a Crocs on. Right? Those who want any, you can message. That's 11. 11. All right, let's see what you Trisha, this boy keep getting logged out. All right, good Nikolai, good Avani. Brandon, good. Hi, Charan, good. Who missing? Oh wait, Stinger log out. Okay, good Olio. Go ahead. Right, so Annalie, yeah, Annalie, go and check it out here for us. Annalie said 1.5. That's correct. Right? 1.5. You're allowed to go to school 35 subjects? Huh? The device. Yeah, no, I was just wondering. It's just like when I give you notes to like come in and write on paper, now you can just write everything on your iPad or something. Anyway, no worry. So let's see how we do in this one. So again, you write the formula. Sum of the anti-clockwise moments is equal to the sum of the clockwise moments. So it will be 50 by 2. That's for this one. Plus 50 by 1. That's for this one. Is equal to 100 by trying to find x. So this is 100 plus 50 is equal to 100x. 150 is equal to 100x. Flip it around. Right? Because whatever you're finding for should always be on the left side. And then divide by 100 here, divide by 100 here. This will cancel. X is equal to 1.5. That's okay? Right? And that's kind of what you will see in an exam type question. Actually, I was going to show you one, but I wouldn't test you out with that. Right, let's change the numbers and let's see if we can get one more right. Okay, last one. Finish. Last one. Here's what doing. Here's what I'm doing, right? Where do I put the 10 kilogram on the right hand side to make it balance off? Where do I put the 10 kilograms? So I have to put this somewhere on the right hand side. So you see where the two fire extinguishers are? I want them right there. I want the two fire extinguishers right there. Where do I put the 10 kilogram? Okay. Where does the 10 kilogram go, right? So I want you to try to figure that out for me. Try to figure out where the 10 kilogram should go to make it balance. Just like the last one. Just the difference here is you have more on the right hand side this time. Try this last one and finish. A little bit harder. Okay, Right, let's check about thing on and everything that's going on. What numbers are there? 5 2 meters away, 5 1.25 away, and 10 over tension. Anybody have something? Oh, I do have that here. Oh. Right, so let's just see what you got. Right, I don't really have it here, but it's like in the middle here, kind of. Right, I don't have the answer there. Right, I don't have it on that scale, but let's just see what we're supposed to get. So you're right, then the sum of the anti-clockwise is equal to the sum of the clockwise.
No.
So it's 50, that is 2 meters away. And then you have the
This
50.
is the form 4s, the new form 4s, as he just admitted.
Yeah, this form 4, the form 5 will start just now, Maria, right? You start just now. Physics unit 2 is in the next week.
Right, online.
Yeah.
For example, online.
Yeah,
Right, so online. But I see that's up.
I start in the next week. Right, so it's 50 by 1.25 plus 100 by x. So this is 100 is equal to what's 50 by 1.25? 62 point. Oh, I work out 7. Anyway, 100x. So that will be 100 minus 62.5 is equal to 100x. So x, let's just switch them around. So 100x is equal to 37.5. So x is equal to 37.5 over 100, which is 0.375. That's okay? And that's it? You good to go? All right. So that is the introduction there. Okay, copy it down, calculate. All right, well, okay there? Yeah, so that's what you have to do, right? And if you're not seeing, come a little closer. All right, well, okay with that? So that's the intro into the principle of moment. Next day, we do something else, right? Most likely we do some thermal next week. That's to give you an idea. What I might also do is show you a past paper to see how the wording is look. We're doing everything, but we just introducing different topics. So like when we go fully into mechanics, we're doing every single thing into mechanics, right? So I just want to give you an idea of what mechanics and thermal and math, all the topics look like. Okay, that's the purpose of the holidays to kind of get an idea what you're getting into. All right. Okay, so nice.